Hello and welcome to another one of D's ADD videos. Today we're going to discuss the homogeneous equation for the imaginary root examples of a second order differential equation. So set up your characteristic equation. In this case it would be r squared plus 9 would equal 0. If you were to factor this, you would get let's do it like this. Let's solve for r, square root both sides, and r would be plus or minus 3i. Okay? So technically what you have here is 0 plus or minus 3i. The general solution for an imaginary root where you have a plus bi or alpha plus or minus beta I would be c1 e to the alpha t sine beta t plus, can I fit it in there? Be close. C2 e to the alpha t cosine beta t. Barely squeeze it in. Okay. So, what is my alpha and what is my beta? You might have A's and B's, doesn't matter, same thing. Well, this one is my 0 and this one is my 3. So we would have a general solution here of C1 E, let's try that sloppy, C1 e to the 0t sine 3t plus C2 e to the 0t cosine 3t. Alright? At this point what happens is this all goes to 1 for the e to the 0t, and you're just left with a purely trig general solution. Again, you could be given initial conditions and you could be asked to solve for C1 and C2 and find your particular solution. We are not going to do that in this one. We're going to stay with the general solution. Okay? Right there. Make sure you practice these. At first, it might seem intimidating, but you can see it's just mainly algebra and knowing your general solutions. So if you practice enough of these, you should be able to get it to become second nature. Make sure you do enough of them to where you see all the different scenarios. The first step in solving for a non-homogeneous or heterogeneous equation is to find the homogeneous solutions, general solutions. Make sure there are no repeated roots. So before you can go on to that phase, make sure you understand this one here, okay? Thank you, and have a nice day.